Yes, welcome back. The battery is full. Let's read some more. I like to drive some American Truck Simulator. It's 1 p.m. Close to 1 p.m. So I will go to my bed and read this Wetland finish. Have Swampland. Maybe I should read the Swampland. Maybe we should do that. And after this, I like to drive some American Truck Simulator game.
Brachiplate system of Valentii migrates more than 3,300 kilometers, 2,100 mi, from its nursery grounds near the mouth of the Amazon River to its spawning grounds in Andean tributaries, 400 m, 1,300 feet, above sea level, distributing plant seed along the route. Productive intertidal zones. Intertidal mudflats have a level of productivity similar to that of some uplands even while possessing a low number of species. The abundance of invertebrates found within the mud are a food source for migratory waterfowl. 97. Critical life stage habitat, mudflats, salt marshes, mangroves, and seagrass beds have high levels of both species richness and productivity, and are home to important nursery areas for many commercial fish stocks. Genetic diversity. Populations of many species are confined geographically to only one or a few wetland systems, often due to the long period of time that the wetlands have been physically isolated from other aquatic sources. For example, the number of endemic species in the Selenga River delta of Lake Baikal in Russia classifies it as a hotspot for biodiversity and one of the most biodiverse wetlands in the entire world. 98. Wetland products. Wetland at the Broadmoor Wildlife Sanctuary in Massachusetts, United States. In February, wetland productivity is linked to the climate, wetland type, and nutrient availability. Low water and occasional drying of peatland bottom during droughts, dry marsh phase, stimulates plant recruitment from a diverse seed bank and increases productivity by mobilizing nutrients. In contrast, high water during deluges, lakes marsh phase, causes turnover in plant populations and increases open water, but lowers overall productivity. From open water to complete vegetation cover, annual net primary productivity may vary 20-fold. 99. The grasses of fertile floodplains such as the Nile can be highly productive, especially plants such as Arabidopsis, giant reed, Cyperus papyrus, phragmites, reed, and Typha, cattail. Wetlands naturally produce an array of vegetation and other ecological products that can be harvested for personal and commercial use. 100. Many fishes have all or part of their life cycle occurring within wetland system. Fresh and saltwater fish are the main source of protein for about 1 billion people, 101, and comprise 15% of an additional 3.5 billion people's protein intake. 102. Another food staple found in wetland systems is rice, a popular grain that is consumed at the rate of 1/5 of the total global calorie count. In Bangladesh, Cambodia and Vietnam, where rice paddies are predominant on the landscape, rice consumption reached 70%. 103. Some native wetland plants in the Caribbean and Australia are harvested sustainably for medicinal compounds. These include the red mangrove, Rhizophora mangle, which possesses antibacterial, wound healing, anti-ulcer effects, and antioxidant properties. 103. The Nepal palm of Asia, sugar, vinegar, alcohol, and fodder, and honey collection from mangroves contribute to human diets and people's income. Coastal Thailand villages earn the key portion of their income from sugar production, while Cuba relocates thousands of beehives each year to track the seasonal flowering of the mangrove of Icenia. 104. Other mangrove-derived products include fuelwood, salt, produced by evaporating seawater, animal fodder, traditional medicines, for example from mangrove bark, fibers for textiles and dyes, and tannins. 105. Overfishing is a major problem for sustainable use of wetlands. Concerns are developing over certain aspects of farm fishing, which uses natural wetlands and waterways to harvest fish for human consumption. Aquaculture is continuing to develop rapidly throughout the Asia-Pacific region, especially in China, where 90% of the total number of aquaculture farms occur, contributing 80% of global value. 103. Some aquaculture has eliminated massive areas of wetland through practices such as the shrimp farming industry's destruction of mangroves. Even though the damaging impact of large-scale shrimp farming on the coastal ecosystem in many Asian countries has been widely recognized for quite some time now, it has proven difficult to mitigate since other employment avenues for people are lacking. Also, burgeoning demand for shrimp globally has provided a large and ready market. 106. Additional services and uses of wetlands. Some types of wetlands can serve as fire breaks that help slow the spread of minor wildfires. Larger wetland systems can influence local precipitation patterns. Some boreal wetland systems in catchment feedwaters may help extend the period of flow and maintain water temperature in connected downstream waters. 107. Pollination services are supported by many wetlands, which may provide the only suitable habitat for pollinating insects, birds, and mammals in highly developed areas. 108. Conservation. Fog rising over the Mukri Bog near Mukri, Estonia. The bog has an area of 2,147 hectares, 5,310 acres, and has been protected since 1992. Wetlands have historically subjected to large drainage efforts for development, real estate or agriculture, and flooding to create recreational lakes or generate hydropower. Some of the world's most important agricultural areas were wetlands that have been converted to farmland. 109, 110, 111, 112. Since the 1970s, more focus has been put on preserving wetlands for their natural functions. Since 1900, between 65–70% of the world's wetlands have been lost. 113. In order to maintain wetlands and sustain their functions, alterations and disturbances that are outside the normal range of variation should be minimized. Balancing wetland conservation with needs of people. Wetlands are vital ecosystems that enhance the livelihoods for the millions of people who live in and around them. The Millennium Development Goals, MDGs, called for different sectors to join forces to secure wetland environments in the context of sustainable development and improving human well-being. Studies have shown that it is possible to conserve wetlands while improving the livelihoods of people living among them. Case studies conducted in Malawi and Zambia looked at how Danboa wet, grassy valleys or depressions where water seeps to the surface can be farmed sustainably. Project outcomes included a high yield of crops, development of sustainable farming techniques, and water management strategies that generate enough water for irrigation. 114. Ramsar Convention. The Convention on Wetlands of international importance, especially as waterfowl habitat, or Ramsar Convention, is an international treaty designed to address global concerns regarding wetland loss and degradation. The primary purposes of the treaty are to list wetlands of international importance and to promote their wise use, with the ultimate goal of preserving the world's wetlands. Methods include restricting access to some wetland areas, as well as educating the public to combat the misconception that wetlands are wastelands. The convention works closely with 5 international organization partners, IOPs. These are BirdLife International, the IUCN, the International Water Management Institute, Wetlands International, and the Worldwide Fund for Nature. The partners provide technical expertise, help conduct or facilitate field studies, and provide financial support. The IOPs also participate regularly as observers in all meetings of the Conference of the Parties and the Standing Committee, and as full members of the Scientific and Technical Review Panel. Restoration and restoration ecologists intend to return wetlands to their natural trajectory by aiding directly with the natural processes of the ecosystem. 69. These direct methods vary with respect to the degree of physical manipulation of the natural environment, and each are associated with different levels of restoration. 69. Restoration is needed after disturbance or perturbation of a wetland. 69. Disturbances include exogenous factors such as flooding or drought. 69. Other external damage may be anthropogenic disturbance caused by clear-cut harvesting of trees, oil and gas extraction, poorly defined infrastructure installation, overgrazing of livestock, ill-considered recreational activities, alteration of wetlands including dredging, draining, and filling, and other negative human impacts. 69. 18. Disturbance puts different levels of stress on an environment depending on the type and duration of disturbance. 69. There is no one way to restore a wetland, and the level of restoration required will be based on the level of disturbance, although each method of restoration does require preparation and administration. 69. Levels of restoration. Factors influencing selected approach may include 69. Budget, time-scale limitations, project goals, level of disturbance, landscape and ecological constraints, political and administrative agendas, and socio-economic priorities. Prescribed natural or assisted regeneration. For this strategy, there is no biophysical manipulation, and the ecosystem is left to recover based on the process of succession alone. 69. The focus is to eliminate and prevent further disturbance from occurring, and for this type of restoration requires prior research to understand the probability that the wetland will recover naturally. This is likely to be the first method of approach since it is the least intrusive and least expensive, although some biophysical non-intrusive manipulation may be required to enhance the rate of succession to an acceptable level. 69. Example methods include prescribed burns to small areas, promotion of site-specific soil microbiota, and plant growth using nucleation planting, whereby plants radiate from an initial planting site. 115, and promotion of niche diversity or increasing the range of niches. To promote use by a variety of different species. 69. These methods can make it easier for the natural species to flourish by removing environmental impediments, and can speed up the process of succession. Partial reconstruction. For this strategy, a mixture of natural regeneration and manipulated environmental control is used. This may require some engineering, and more intensive biophysical manipulations, including ripping of subsoil, agrochemical applications of herbicides or insecticides, laying of mulch, mechanical seed dispersal, and tree planting on a large scale. 69. In these circumstances the wetland is impaired, and without human assistance it would not recover within an acceptable period of time as determined by ecologists. Methods of restorationist will have to be determined on a site-by-site basis, as each location will require a different approach based on levels of disturbance and the local ecosystem dynamics. 69. Complete reconstruction. This most expensive and intrusive method of reconstruction requires engineering and ground-up reconstruction. Because there is a redesign of the entire ecosystem, it is important that the natural trajectory of the ecosystem be considered and that the plant species promoted will eventually return the ecosystem towards its natural trajectory. 69. In many cases, constructed wetlands